Hi, good morning or good evening, I guess, to those of you who are a bit further away. So I teach grade 11 and grade 12 biology, and I've had the pleasure of having Johannes in my class for 2 years now. So right now we're working on protein synthesis, and it can be a bit of a challenging topic for our students to kind of wrap their heads around. I'm just going to share a screen that kind of shows you one of the online programs that we use. This is a program called Gizmos, and we use it at St. Andrews from essentially from grade 9 all the way up to grade 12, so it's a very versatile program. It's an interactive program that allows our students to see perhaps like microscopic level things in a way that they would not be able to in a classroom with the materials that you would have in real life. So when we're looking at protein synthesis, usually I'll start the students off with a simpler activity. So with this simple activity, it goes through the steps of protein synthesis and how it works. So I'm just showing you, this would be the introductory activity where the students would practice matching nucleotides to practice the base pairing rule. So this would be an introductory level lesson. And then once the students are comfortable with the concept, then we move on to something a bit more exciting. So for our, let me just move this bar out of the way. So for our higher level thinking, Gizmos also offers case studies. So the grade 12s this week have been working on a case study that has them acting out a role as a pediatrician. So they're given a problem, they're given a patient, and they have to try to solve what sickness or what illness this patient has. So from the teacher screen, this is what I would see. So I'm able to go through all the different sections at any pace I would like, but the students would have to go through it step by step. And then as the students are going through it, I'm able to watch their progress. So I can see here that my first student has only answered 3 questions, and then I have another student who has, some students have gotten all the way to the end. So as the students are working through it, I'm able to see their progress in real time. So I'm going to hand this over to Johannes, who's going to show you guys some of what he's been working on this week.
Hi everyone. So on my end, it is actually, as we just saw, it starts the exact same as what Ms. Sozzi's. So we are just giving a problem that we have to solve. But at the beginning, we only have small questions like, oh, how are the blood levels different? But we can all agree that in biology, sometimes definitions are not the most fun thing to learn. And with this program, it really gives me, at least, a really good opportunity to show animations and show what's going on in the cell, even though we cannot do that in a regular classroom. And for what we do as a class is we have such a good environment in my class, at least. So we normally break up into breakout rooms where, let's say, me and 2 friends are talking about how we can answer these questions. And further on in the case, we have to write the conclusion, which is basically just our case summary, which is something I just wanted to show. I have not started that yet, but it just shows you have to go through this whole experiment with diagnosis. For example, if we want to look at an active site mutation, we can look at, which one will it be? And further on in the lab, we will have different questions. At the beginning, it is more like, I look at a graph, which one is different? But further on in the lab, they get really difficult, and sometimes it's hard to answer as a singular person. So that's why the interactivity between me and 2 or 3 friends working on this lab together is so great that we have that available to us, because it's just really hard to see or work on it normally, because it is quite difficult if we want to do this by ourselves. And with these animations I'm showing you right now, it really shows you how we can work, or how different things in our body work, even though we can't see it ourselves even in a lab in school. So having these things really makes it easier for me as a student to look at things that I don't normally get to look at. And then throughout this whole experiment, we have to write a hypothesis at the end. What do we think will happen before we actually know what will happen? And obviously with what we see here is normal range stats to compare to our patient stats. And we have to obviously then look at how we can get problems solved. And at the end, you get to do, which is a nice thing, you get to look at if your hypothesis was correct and to see if you can actually help the patient. And at the end, my hypothesis was correct, and then you can actually in detail learn about how you can treat ADA with stem cell treatment. And what I also really like about this is if you don't understand any word in the whole thing, you can have a whole word bank of definitions to help you understand each and every single word in this presentation.
That's awesome. Thank you so much for going through that for us, Johannes. I love these Gizmos case studies because it has the students go through the actual scientific inquiry process. So as Johannes showed you, he's presented with a problem. He has to come up with his own hypothesis of what is causing the problem. So it relates perfectly to what we were learning in class. When we talk about DNA mutations, again, that's something that's very difficult to see if we're in the classroom. So by using these sort of simulation tools, the students can see how one mutation in one base pair can suddenly lead to an entire protein not functioning correctly. And then that protein not functioning correctly can result in disease or disorder. So it kind of links everything from the smaller scale to a larger scale of how it affects the organism as a whole. So from my teacher side, I can see how Johannes has progressed through this simulation. If I look at his final, so for example, this is another student, he has written a conclusion, so I can see that he has explained the problem. He talks about how the mutation led to the disorder, and they have to go through it and provide explanations and evidence for all of their claims. And then I'm able to grade it and also provide comments to them after reading their final report. And of course, as Johannes mentioned, our school uses Zoom or Teams, so the students work synchronously with me and with each other. So Johannes will be in a group with other students and they'll talk through the problems together. They can ask each other for help, but if they're really stuck, they can also ask me for help. So during a certain period of time, I'm interacting with those students and I'm providing them whatever support that they need. So I hope that kind of gives you a little glimpse into some of the simulated activities that we're doing here at St. Andrews.